All right, today we're doing section 3.5 and 4.1. It talks all about triangle sum and congruent figures, and mainly congruent figures with triangles. This whole chapter is devoted from triangles. So let's look back or think back to your prior knowledge of triangles. There are two different ways to classify triangles, giving them names, by sides or by angles. So by sides, the name scalene identifies triangles with no equal sides, okay? For isosceles, they have 2 equal sides, and equilateral, 3 equal sides. With angles, when we talk about triangles with acute angles, they have to have 3 acute angles. If it's an obtuse triangle, it has 1 obtuse angle. If it's a right triangle, it's going to have 1 90-degree angle, and equiangular actually has 3 equal angles, which will end up being 60 degrees, and you'll learn that here in a second. So let's go and talk about the main idea for 3.5, and it's the triangle angle sum theorem, which states right here, which you might already know or remember from other math courses, that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. So in any triangle, all 3 angles add up to give you 180. So let's do these 3 together. First one, 60 plus 43 plus x should equal 180 because of the triangle sum. And when you simplify and subtract out, you should get x to equal 77. So this angle here is 77 degrees. All right, then second one is very similar, except for there's more variables. So 3x plus 2x plus 4x equals 180. So when you simplify and combine like terms, you should get 9x equals 180. And then divide both sides by 9, so x equals 20. And if you actually wanted to plug these back in, you would do 2 times 20, 3 times 20, and 4 times 20 to get those angles. Okay, the last one just has more variables. It's going to be a longer Algebra 1 problem, so hopefully you can do this on your own. Go ahead and pause it, and then I'll show you guys the answer. All right, so hopefully after you did your algebra, you should have gotten x to equal 25. And take note that this type of triangle, 2 equal sides, this would have been isosceles triangle, just so you guys know if they asked you to classify that part. Okay? So that's the triangle angle sum theorem. All interior angles equal 180.
All right, let's talk about something new, the exterior angle theorem. In order to know the exterior angle theorem, we got to define 2 things. Notice I have a linear pair out here. The guy that's not in the triangle, angle 1, is my exterior angle. Okay, so he's the guy that this whole theorem revolves around. The other 2 guys that are really important players in this theorem are angles 2 and angle 3. Those are called remote interior angles because they are the furthest away, like a remote island, from angle 1. So these are my remote interiors. Okay? All right, now the theorem says that the measure of angle 1, the exterior angle, is equal to the measure of angle 2 plus the measure of angle 3. In other words, the exterior angle equals the sum of the 2 remote interior angles. I'm going to show you this real quick in a visual image. So here's angle 1. Okay, we'll move him down here so we can kind of manipulate him in a second. We're going to do the same thing. Here's angle 3. All right, we'll move him down here so that he is workable. And then we're going to outline and trace angle 2. Okay, so what we're saying this theorem is that angle 2 plus angle 3 should fit exactly inside angle 1. So I'll go ahead and put angle 3 here so the vertex lines up and the sides line up. Angle 2, I'm going to have to do some rotating. See if we can get him to fit. And he fits exactly inside there. So notice it does work out that angle 1 is equal to the combination, the sum of these 2 angles. All right, let's put this into action with 3 example problems. So y here is my exterior angle in this first one. These are my 2 remote interior angles. So my equation is going to be that y equals 70 plus 88. So simplify that, we get y equals 158. Okay, so that's it. That's our final answer. Looking at the second one, keep in mind this square here means 90 degrees. So 3x plus 42 is my exterior angle. He is equal to the sum of 90 plus x plus 6. We're going to go ahead and combine like terms. Go ahead and try that on your own real quick. Pause it, come back. All right, now that you guys have solved this, you should have gotten that x equals 27. And again, as Ms. White said, you can take this back in and plug it in and find out what the other measures of the angles actually are, which you're challenged to do in this third problem. Take a second, try this one on your own. See if you can find not only x, but the measure of the exterior angle. All right, so if you've done your work correctly, we get x equals 10. And we get that the measure of the exterior angle, which is this guy right here, is going to be 120 degrees. All right, 4.1.
All right, so right now you probably should pause it and take down these two definitions of congruent figures and congruent statements. Congruent figures say that all parts of one figure are congruent to the corresponding parts of the other. So we're going to talk about this corresponding here in a second. Pretty much in general terms, it just means both figures are the same size and same shape. We will talk more about triangles, but we'll throw in some other shapes. You add on another side, the concept's still the same. We're going to be talking also about how to write a congruent statement. Okay? A congruent statement just says, it's a statement that says this figure is congruent to the other figure. And really there's not the definition, but you need to remember that you're listing the corresponding vertices in the same order. So what we're going to do first is look at these two triangles here, and we're going to list all the corresponding parts to these triangles, which means there's 3 sides, 3 angles. That's what we have to write down. So the first one, I'm just going to pick angle K to start. Angle K has 1 arc here, so we just have to find the other angle that has another arc. So that's going to be angle S. So we know angle K is going to be congruent to angle S. All right, moving on to the next one, we'll do angle L. Angle L is going to be congruent to the other angle that has 2 arcs, which is angle R. So angle L is congruent to angle R. And finally, our last 2 would be angle J being congruent to angle T. So those are by our angles. Those are the corresponding angles. Let's go ahead and look at the sides then. I'm going to start with side JK. You can start with any side. Side JK has 1 little notch there. So you're going to find the other one, which would be side ST. So JK, and now pay attention, since I started with J and it has 3 arcs, I need to actually start with T because T has 3 arcs. So that is congruent to side TS. All right, let's pick another side. I will do JL. Okay, side JL is congruent to, that has 3 notches. So over here, 3 notches would be side TR. And I'm going to start with T again because I used J first. And J and T match up. Okay, last side would be side LK. LK is going to be congruent to the other side that has 2 notches. So LK, L has 2 arcs, R has 2 arcs, so I'm going to put R first. So side RS is the congruent part to that. Okay, so those are listing the parts. Now, we're going to talk about a congruent statement. Okay, the statement actually talks about, all right, is this triangle congruent to this triangle, and the order matters. So I'm just going to start with the triangle that has the vertices JKL. So triangle JKL. And this little symbol here, that's the little triangle symbol. That's how we notate a triangle. And you just list the 3 letters of the angles. Now I'm going to put a congruent symbol here. And I'm going to take a look at the order of what I put my JKL in. Since I put J first, okay, J's here, we take note, I've said J and T over here are congruent. So since J's first, T has to be first on my triangle. Okay? K is next. Well, over here I put K being congruent to S. So S has to be next. And finally, L, and then L matches with R. So TSR is the correct order. It has to be in that order. So what if I wrote the order differently? Triangle KLJ. Well, we can still say that's congruent. I just mixed up the order. So let's take a look at the order. So if I put K first, then I have to put S first. So this will be congruent to KLJ, congruent to SR, and then J matches with T. So that's also another congruent statement you can write. There are several ones. You just have to make sure that it's the same order, that they're listed in the same spot. If you also notice, now that I just did the angles, that matches up the sides. So JK and TS match up. Okay, and we wrote that up here. JK and TS match up there. And so those two sides are congruent. KL and S are congruent. And then finally you have JL and TR. So by matching up the angles, the sides automatically match up. Okay, so that's a congruent statement.
All right, so we're going to use congruent statements to go ahead and solve for missing variables. Before we start this, we have to write the congruent statements ourselves. Notice the picture is not facing the same way. So I'm going to use what they already gave me. Just like Ms. White said, this matches up, it's in the same order. So I know, therefore, that angle D is congruent to angle S, angle E is congruent to angle P, and we can keep going with that. So these are our congruent statements, okay? Notice again, this is D, E, F, G, and then S, P, Q, R, just like we have in the congruent statement up above. Just like we did in the triangle, again, you have D, E, and S, P, so that's where this is coming from right here, and we followed suit with the rest of that. If you notice the variables in the problem, this angle has X and Y in it, so I can't solve for that first. I've got to know what X is, so that's why we're going to find X first. So using my congruent statement, my X value is in the side QR. So I come over here and I know that QR is equal to FG. So I'm not writing a congruent statement, I'm writing an equation. QR equals FG, so that's why the bars are left off the top of this. Let's use substitution property, and I'm going to plug in what the diagram says. 2x minus 4 is equal to 12. All right, so now that we go through and solve this, I get 2x equals 16 and x equals 8. So I've accomplished my first goal of finding x. I still need to find y, so we're going to take that and plug it back in right here. So we've got that 6y plus x, which is 8. We got to figure out what to set it equal to, though. So this is angle Q. The measure of angle Q is equal to, and if you come back over to our statements again, Q is equal to F. All right, so angle F back in my diagram is 68 degrees. Okay, so now we solve the problem. We get 6y equals 60. Divide, and we get y equals 10. So the final answer is both of these things. X equals 8 and y equals 10. The third angles theorem pretty much goes back to that first theorem of all three angles in a triangle add up to 180. In this particular picture, it says if two angles in one triangle are congruent to two angles of another, then the third angles are also congruent. So we see in this picture, we have angle B is congruent to angle Q, that's 1. We have angle A is congruent to angle S, that's 2. Therefore, angle C must be congruent to angle R. Well, if I want to use this to help me find out what X is, then I should probably use the first theorem that all three angles add up to 180 and find angle C. Okay, so we're going to do 180 minus the two measures that are given, 80 plus 45, and we get that angle C, the measure of angle C, is equal to 55 degrees. So now I've got enough information to solve for X. Since angle C is congruent to angle R, we know that 55 equals 5x. So X equals 11.
Alright, so that's it with section 3.5 and 4.1. So here are two questions at the top that you should know by the end of this. Do you know what the exterior angle theorem states? And do you know how to write a congruent statement? This last challenge question we'd like you guys to try on your own. The angles of a triangle are in the ratio of 1 to 2 to 3. Find the measure of the largest angles. So see if you can do that on your own and bring it to class for tomorrow.